In this lesson, we're looking at average rate of change using quadratic and polynomial functions. This lesson is intended for students who've already taken Algebra 1 and perhaps geometry going into Algebra 2, or if you just want really just an overview of these functions, stay tuned for that. But if you're looking for a detailed lesson on this information, watch my other videos on quadratic and polynomial functions that I will link in the bio of this video. But if you just want an overview of this lesson, average rate of change and quadratic and polynomial functions, stay tuned. Let's get started. First, let's explore the average rate of change. The table below shows the temperature T in Tucson, Arizona, T hours after midnight. When does the temperature decrease the fastest? Between midnight and 3 a.m. or between 3 a.m. and 4 a.m. And so here we have our hours here from 0 to 3. And so this is after midnight. So at 0, this would be midnight here. And this would be 3 a.m. and this would be 4 a.m. And so we're looking at the rate decreasing the fastest. And so even though the temperature drops more between midnight and 3 a.m. than it does between 3 a.m. and 4 a.m., the temperature decreases the fastest between 3 a.m. and 4 a.m. So if you notice here, our interval from 0 to 3, the temperature drops 9 degrees, but our rate of change is -9 divided by 3, which is an average rate of -3 hours, -3 degrees per hour. So again, rate of change is kind of like finding the slope. And so it dropped 3 degrees every 3 hours here. But if we look at the interval from 3 to 4, this is just 1 hour here, and it dropped 6 degrees in just 1 hour. And so although again from midnight to 3 a.m. it dropped more, the fastest decrease or the fastest rate was within that 1 hour period because it dropped 6 degrees. What exactly is the average rate of change? Well, it is the change in a function divided by the change in the value of x. In other words, we have this formula here: a of x is equal to f of x minus f of a over x minus a. Basically, this may look familiar to you if you think about the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Same process here. And so we have a polynomial function right here. We have this graph. And we, for example 1, it says given a function f of x is equal to x to the third minus 4x, what is the average rate of change for f over the interval -2, 3? So basically our interval will always be our x values. And so we could label our graph here x1, y1, x2, y2, or we can label this table here. These are ordered pairs. So see, we have x and f of x equals y. So x1, y1, x2, y2. And we're basically just plugging it in. And so our change in y values would be 15 minus 0. And our change in x would be 3 minus -2. And that reduces to 5, or that is simplified to 15 over 5, which reduces to 3. Again, similar to using the slope formula here, it doesn't matter what you label, x2, y2, x1, y1, as long as the values there are corresponding, you're going to get the same answer. Now let's take a look at the average rate of change for a quadratic function here. It says consider the function x squared minus 9, and we have the graph of this quadratic function here, and we're asked to find the average rate of change from -2 to 0. So again, that is denoted by our x values, and so we're looking at -2 right here and 0 here. And so these will be the ordered pairs that we use, and we can label this x1, y1, x2, y2, and again just plugging it in. So if it's easy for you to use f of x and f of a, that is fine, or x2 minus x1, you get the same result there. And so we have negative 9, which is our x sub 1. I'm sorry, y sub 2. Negative 9 minus negative 5 right here. So we're subtracting our y values, or changing our y values, and then you're over changing your x values. 0 minus negative 2, because we have a minus in that formula, we have that double negative there. Simplifying, negative 9 plus 5 will give us negative 4. 0 minus negative 2, once again we have that double negative, so that is really 0 plus 2, and just reducing that we get negative 2 for our average rate of change for from negative 2 to 0. Let's look at part B. It says find the average rate of change from 2 to 3. So again, x values that we're looking at here. So x1, y1, x2, y2, and plugging it in. So our change in y values, 0 minus negative 5, we get 5, and then 3 minus 2, we get 1. So again, if you flip it, it does not matter. We could do negative 5 minus 0 over 2 minus 3. Let's see what happens. That is negative 5 over negative 1, and that reduces to positive 5. So you're going to get the same answer regardless of what you use for your first and last x and y values, as long as those terms correspond. For example 3, I would like for you to try this problem on your own. It says Miss Giovanna Bailey is an accountant for a major sports firm. She is recording the number of documents she has yet to process each hour. The data is in the table below. We want to find the average rate of change from the intervals 4 to 6 and say what this rate of change means in this context. So go ahead and pause the video and try this problem on your own. Go ahead and check your answers. The average rate of change was negative 9. And if we look at the ordered pair here, 436 and 618. So again, we're using those x values there for our information. And you should have gotten negative 9. And the rate of change represents Mrs. Bailey processes an average of 9 documents per hour. And so hopefully you got it correct. For our last example here, we want to find the average rate of change of this polynomial function, but we have 3 parts here. So part A, it says find the average rate of change in y over the interval negative 10, negative 8. And so our interval is representing those x values here. So we have this ordered pair at negative 10, 0, and at 8. So when x is negative 8, that would be negative 8, and our y value would be 8. And so I'm just going to rewrite it over here, negative 10, 0, and negative 8, 8. Label this x1, y1, x2, y2. Plugging it in, we get 8 minus 0, or using our rate formula, 8 minus 0 over negative 8 minus negative 10. So 8 minus 0 is 8, and we know that negative 8 minus negative 10 is going to be plus. We got that double negative. So negative 8 plus 10 is a positive 2. So our average rate of change from that interval from negative 10 to negative 8 would be 4. And what I would like for you to do is try these last 2 problems on your own. Go ahead and pause the video, find an interval or the average rate of change from 4 to 8, and explain which average rate of change is greater. For part B, you should have gotten that average rate of change is 3.5. And for part C, for which interval above is the average rate of change greater? It is the interval from negative 10 to negative 8, because the average rate of change is 4, whereas from 4 to 8 it is 3.5. We've reached the end of our lesson. I want to thank you for learning with me. Some related videos are key features of linear, quadratic, and exponential functions, as well as intro to quadratic functions and constructing exponential functions. If you haven't already, please like, comment, share, and subscribe, and click the bell to be notified whenever I post new content. And once again, I want to thank you for learning with me.